done and start recording locally. Okay. Hello, everybody. Today's class is reflections, as we did yesterday. And the idea is to do something that looks nice in the engine. I'm not going to use the previous engine I was using until now, the one where I have all the algorithms. I'm going to start from scratch with this version because, well, I think it's going to be faster if I use just a clean scene that not with all the things from the other classes. I will go a little faster. So obviously there is not going to be any illumination here. What we're going to do is just to generate examples of how you can make reflections on an engine. And I don't know how I will display it. I will try to display it somewhere. Okay, so as I said, there's three main algorithms when you want to talk about reflections, which are planar reflection, cubemap reflections, and screen space reflections. Screen space reflections take a lot of time to develop, so we don't have time to do it. It's a pity. It would be nice to as a feature. And also, I never have coded it. I have to be fair. Never have the time to code screen space reflections. And I know that if you don't code it very well, the results are not very good. And also the performance is very bad. So it's one of those algorithms that you need to optimize a lot if you want to use it. So that's why I never spend too much time doing it. Okay, but the other ones I have been done a lot of times. And so let's go with the most basic one, which is cube maps. As we said the other day, we have a cube map here, which is this beautiful sky. And we can apply that from on the shader to any object if we want it. And that's kind of simple. We just go to our shaders file. 1 second, I haven't opened it yet. So yeah. So here, for instance, when I'm computing the color of every pixel, I'm using, if I recall correctly, if I go to the pipeline, to the render, to the function that I'm using to render the material. Here, this one, which doesn't have any illumination, but here we are using this shader called texture. Yes, for now, because I don't have too much time and I don't want to rewrite that one in case I want to use it later. Let's have I don't know, light, just to put a name. I mean, this is the shader that you already have, so don't worry so much. And I'm going to just copy the texture one and call it light, so I can modify it without, well, destroying the old one. Imagine that this was one that has all the lights and everything, and we can test if this is the right one. I don't know. I'm doing something as silly as saying that the color X is equal to 0. So if I execute this, I should see that the color of every object is like cyan, because there won't be any red color. Did I change the light on the execution function here? No, I forgot this one. Okay, so cool. So now I execute it, and I should see everything in some weird color, bluish cyan color, if everything goes well. And as I said, it takes a lot of time to compile in my computer. Damn it. I hate that. It wasn't happening until, I don't know, like 1 month ago. Okay. So compile. Everything looks well, good in the console. It's loading the assets and where everything is cyan. So good. Cool. So we remove this because it makes sense. So one thing we are going to need is probably some sort of cube map. Okay. And in this case, having a cube map, it's easy. Remember that cube maps are just kind of texture, so you can pass it here. Let's call it. They call it usually the environment map. Environment. It's the name that we usually use for that texture that is very far away from everything. Also, skybox is more the way we render it on the screen, but the environment is a texture. So if I have this texture, obviously I need this texture here. So I'm going to upload it to the GPU. So in this case, I know that there's this skybox cube map here. So I can go here and say the sky, like here, environment. And I'm going to upload this texture, and I'm going to use another slot 8. I don't use the next one because I usually like to have all the materials one to each other, and the cube map on the 8th one. I think it looks more, I don't know. I know which one it is. The cube map always is in the 8th one. I also have to say that every time we upload any texture to the shader. We're usually using this kind of setting the texture every time in the shader. But I mean, we can just leave the texture on the slot number 8, and we only have to say the shader, the texture is in the slot 8, so we don't have to bind to the slot. I think binding to the slot is a slow part. Telling the shader where is the texture, in which slot it is, it's cheap. But anyway, that will be some kind of optimization that I don't want to do now. So we have the environment texture, and one thing we can do here is we can try to see if we can see anything. So I don't know, imagine I take the normal on this pixel. I'm going to make it a little bigger maybe, and take this normal and use it to read the color. So I'm going to say, hey, the color is go to the texture, and the texture, call it U environment, and using the normal vector, read from this texture. This will look horrible, probably, but just as a first step. It will look horrible because here, what I'm doing now, it doesn't make much sense. If I have an object like here, in this pixel here, no matter what I'm looking at, it's going to take this pixel on the cubemap. Here is going to take this pixel, and here is going to take this pixel because we're using the normal. And this is not correct. If we want reflection, we should take the reflected vector, okay? But anyway, I just wanted to show you that, I mean, you can use the cubemaps wherever you want to. You can read in any direction. And oh, it crashes because I forgot to put the X, Y, Z here. Sorry. And while it's doing this, maybe I should be computing the R vector. E by the N. So this way, say, I mean, now we are reading the cubemap, but it doesn't make any sense. This doesn't look like a reflection. You can see that every object is reading the cubemap, but it doesn't look like a reflection because I move the camera and the reflection stays constant. And obviously it stays constant because I'm using the same vector for the same pixel. So they see the vector is always the same. No matter where I look at it, it's always the same. So obviously we need the camera position, which I don't have here. So let's put it here. Camera position. And as long as I have the camera position, I can compute the vector E. And if I have the vector E, I can do it. So in this case, let's go with and do I have the camera? I do have the camera here. Yeah. So the camera position is in the camera I. Okay, so we have the camera position, and that means that if we subtract if the vector has to go from the I to the position, that means wall space, the wall position, wall position, this one over here, which is where it ends, subtracting the camera position and normalizing, I have the E vector. Okay, so now I have the E vector. I can reflect it and use this reflected vector R as the reflection vector here. And if I do this, when I render a pixel, it's going to take from the cube map the right direction. So let's see how it looks like. And as you can see, this is quite cheap. I mean, we're not doing any complex computation here. And now we will see some kind of liquid metal scene where everything is reflective here. So you can see everything is reflective. The cars are reflective, the wheels are reflective, the glasses are reflective, even everything is reflective because I'm applying the same to every pixel, okay? And this looks like reflections, but as I said, the effect reflection, we are reflecting the skybox, the environment map. And that means that, for instance, I don't see the inner reflections within an object within itself, but also I don't see in between reflections between two objects. So I don't see in this case anything reflected in front of it. Okay, so obviously, if the whole scene is reflective, it's not going to work using cubemaps. But if this was more subtle, I mean, I'm using a lot of factor here. Instead of, I mean, I can have done this, something like this. So I can say that this is the reflection color, or reflected color. Okay, and I can say that I want to make a linear interpolation between the current color, the reflected color, and some factor. I don't know, 0.5 in this case. If I do this, you will see that now, because the reflection, I mean, I have half of the color of the object, half of the reflection. Okay, it's not so obvious, at least not in the car. Obviously here on the wall, yeah, it's a lot. But if we wanted to go a bit further, remember that we can send to the shader the metalness texture, and that texture contains information that we can use as a value to say which parts should be more reflected and which parts should be less reflective, okay? So for instance, I can do that because it's kind of cheap. I can go here, and when I'm uploading the textures, let's call here the matte texture, and here matte texture. I upload the matte texture, otherwise I upload the white one. And here, this is going to be the albedo texture. Okay, and I'm going to remove this. I think this looks better. So now when we start, we have the albedo texture, and the albedo texture is going to be this one over here. And for the matte texture, and also I can use maybe something like that. Okay, so we have both textures, the albedo and the metallic roughness texture. Okay, and if by any reason one of these textures it's white, if the albedo texture, sorry, and we also have another texture, which is the white texture, and it's always useful when, because we are going to multiply, so white. Okay, so we can always say that if we have the, what it is here, the texture, the albedo texture, then we use the albedo texture, otherwise we use the white one. And the same for the matte texture. And it's complaining about something here. Ooh, here, sorry. Yeah, okay. So now we have the text, the albedo, which is called texture, and the matte texture. And that means I can go here to my shader, and I can have here a texture 2D sampler, and I'm going to read from this. So like matte using the VUVs. Okay, so now we have all the information about the material, and I was using this value before, this reflective factor. Okay, I was saying 0.5, but I can say that go to this matte texture and take the Y, I think is the metalness or the roughness. I never know. I think it's the Z. So this is reflective factor is going to decide to which area should be reflective. And I put the environment, the matte texture is here. Okay, I think it should work. So everything goes well. We should see that some areas are more reflecting based on the materials, and some areas are less reflective. It didn't crash. It's a good signal. It's loading. And it crashed because it's complaining in this line here. This is wrong. Matte texture, sample 2D, VUVs. Sorry, it's UV. Yeah, I can use VUV or VUV is the same, but yeah, thank you. So, and I have to exit again. Damn it. Okay. Okay, so everything is reflective now. Too much, I think. I think I'm using the roughness, not the. Yes, now it's loading the texture. Yeah, sorry, it didn't load the texture, so it was white, and white means it's too reflective. So I don't know. I mean, here you can now. I don't know. Oh, I think I did it in the wrong way. Yeah, I think the texture I'm using is not the right one. Always when I have doubts about which texture should be using, and I'm not sure, always remember that you can go here, takes this texture. I don't know what's the matte texture here. And I want to see this one. So I'm going to go here and make it visible. So okay, so I'm going to put the matte. I think it was the Z, the one I used, the reflection factor. So if I do this and I reload, we can see this makes sense. I mean, the dark areas are the more, no, this doesn't make any sense. The tree shouldn't be so bright, maybe. But these are areas that are, and I think this is the roughness. If I go to the other one, the Y, No, this is the roughness. So this was right. Yeah. Anyway, the thing is that I didn't take into account the material properties of the constant, the factors of the material, the metalness, roughness factor that doesn't come from the texture, and that's why the tree, for instance, is very reflective, and the floor, because that factor is very low. Remember, if I go to the floor doesn't have a texture to say that it's very, well, it is that has texture, but also it has this factor here. Sorry, yeah, I didn't expose it on this editor, but there's a factor that you can control how much metalness on it, and I think that it has very high one. Anyway, so we can have something to control how much reflection do you have in any surface based on the properties of the surface. But as I said, the problem we have here is that if you pay attention to the reflections here on the, I hate that the floor is so reflective. 1 second, I have to fix this, because otherwise when I do the other reflection, it's going to look horrible. So let's have vector 2 matte properties, and here I'm going to put both things. So matte properties, I'm going to put here from the material the metalness factor, and on this first one, and on the second one, I'm going to put the material roughness factor. Yeah, this one's okay. So at least now I can read this from the shader and have proper, the reflective factor has to be this multiplied by the X, because I think the X is the metalness. That should work a little bit better. Otherwise, the floor is going to be super reflective, and I don't like that. As I'm not taking into account the roughness now. So obviously it doesn't look perfect. And keep in mind that when I'm doing all this, I'm not taking into account anything of PBR. I should be using the PBR functions, using the Fresnel and all those things. But for the class of today, I don't have too much time and I don't have the PBR implemented here. So that's one of the things you have to do. You have to implement these kind of things inside the model of PBR. Okay, cool. So yeah, now the floor is not super reflective, which was kind of annoying for me. Okay, so another thing we can do always is that you can see that the reflection is always the same, no matter from which angle. Like if I'm looking straight here, there's a reflection, and that's not how it works. Remember that reflection works depending on the angle, that Fresnel. I don't have here a good equation for Fresnel, so I'm going to use the more scrappiest function you can find, which is the Fresnel is the, I'm going to put it before. It's, remember what's the Fresnel, it makes the reflections be bigger. It reflects more the more the angle is less perpendicular. So to do that is just we compute the dot product between the I vector and the normal vector. Okay, so that gives a number between 0 and 1 mostly, and if they are perpendicular, both will be opposite, and that will be -1. And if they are, so I'm going to, I think it looks better if you put negative here. So what I'm trying to do is if two vectors, the I vector is this one. No, this vector goes final to, it goes from wall position to camera. So the final is this one. So yes, this is the I camera now, and the normal is this one. And I want to both of them to be in the same direction. So that's why I'm negating the E on the Fresnel here, and doing the dot product will give me the cosinus of this angle, and the cosinus of this angle, when they are very similar, is going to be 1. When they are perpendicular, is going to be 0. Otherwise, it will be negative. So we're going to clamp this value between 0 and 1. Okay. And the thing is that I want the opposite. I don't want that, like, I don't want when they are opposite, when the vectors are very on the same direction, like here, I want it to be 0. There's no reflection. And when they are very, you are looking from the side, something like this, when the angle is almost 1, this one, that I want it to be 1. So that for that, I can invert it here and say 1 minus this. So this factor, if I multiply it now by the reflectivity factor, I save, I go back, I reload, it crashes because I put, damn it, a comma instead of a point, damn it. Thank you, David. Too late. I have to wait to compile and load everything. I should not be working on the back. I should be working on release. That will be way faster, but okay. Go. It's here, sorry, I didn't saw it. So as I was saying, you can see that there is no reflection now. Before there was a lot of reflection here, but if you look from the side, there's reflection, okay? So less reflection, more reflection, okay? And that's a good thing. That's more close to what I would expect from materials, that there's more when you see it. Also, keep in mind that if the object is very metallic, that shouldn't apply so much. This only applies when the object is not so metallic. So here, this solution is very ugly. I'm just doing it now as an example that you can play around with these factors if you want to make a very crappy reflection. But when you have PBR, you know the Fresnel factor. Okay, so you can use that Fresnel factor as the factor here for the reflections. Okay. Cool. So we have a way to use cube maps for reflections. And by the way, this factor here, it's horrible. So I'm going to try to change a little bit the curve. I don't know if this is going to improve a little bit, but I wanted that there's, this is the opposite. It makes it stronger. And if I divide this, it's, yeah, I don't know. I just want to have more reflections because I want to play more with the reflections. Okay. So we have some very basic reflections, but as I said, they are not taking into account the environment. So let's try to do something to take into account the environment. So let's create a new object on our rendering scene, and let's call this object something along like, I don't know, reflection probe. So reflection probe. And this object, we are going to need two things. Where's the position where this reflection probe is going to be position stored? And obviously, we are going to need a texture to store this reflection probe. And that's all I need. I need to know where it is and where I'm going to start where I'm going to store all the information about the reflection probe. Okay. And the idea now is that if we have a scene, like here, we have a scene with a car or whatever, I'm going to mark this point and I'm going to compute the reflection doing 6 renders, one every direction, up, down, left, right, top, front, back, front, and store all that information in a cube map that is going to stay on the GPU. Okay, and then when I'm rendering the car, for instance, I can pass this cube map because it will be much more aligned than the skybox that we're using with the scene. So for that, we're going to need to know the position of the reflection probe, and where we compute it, I'm going to need to have a place to store it. Okay, and here I can put here a function like capture reflection, where I'm going to pass reflection probe, and that's it. And it's going to update this reflection probe. By the way, I didn't put here a null, and that's dangerous. Can I do this? Yeah. Previously, it wasn't forbidden by C++, but now it seems that they allow you to do that. Cool. Okay, so we have a function. Let's go wherever we want to here, maybe. And store here the reflection. Okay. First, we need to have some prof to test this. So let's create one as a test, although in your code, it would be good that you can support many of them and you use some structures to store them. And this kind of information should come from the description of the scene on the JSON, but we don't have time to do that. But you can create your own entity called reflection prof entity and using all the hoops to create more, put on the JSON, and then that means that you can define the scene with all the prof. But for now, we're going to have to go with the simple solution, which is I'm going to have a prof, and when my application starts, I'm going to put this prof in a position where I feel is going to be like close to the car. And for that, I'm going to need to have a function. The way I didn't store this function. Yes, I have it. I need to find a position on the map that it's like a bit centered and that we can use. Also, besides capturing the reflection, I'm going to need to have a function to visualize that prof. So I'm going to do both of them. So while it's loading, let's go and add here render reflection prof. Okay, both functions are going to be very handy. So as I said, I need to know the position to put it. I'm going to put it here. And if I go here, the camera is 46, 81, 56. I remember it was like 50, 50, 50 was a good place. So yeah, 50, 50, 50 is going to be. So go here and say that the prop is going to be in position 50, 50, 50. And we need to capture it. When do we going to capture it? For now, I'm going to capture it with a key or with a button. So as we did the other day, it wouldn't be so problematic to put here some button. As you can see, this looks very similar to what we did the other day with the Radiance Prof. There's more or less something very similar in these both solutions. And capture reflection. But this capture reflection, we have to pass some prof. So yeah, no, yeah, they're going to pass the prof we defined previously. Sorry, yes, I'm silly. This is a function. This if this. Okay, so that's it. If we click the button, we capture the reflection. If we call the reflection, we're going to, what we're going to do? What we need to do is render 6 times the scene. Because we're going to render to a texture, obviously, we're going to need to have an FBO. So we need a new FBO. Let's define it maybe here. Reflection FBO. That is going to be null. And that's it. And when we compute the reflection, what is this? Why is not going to the function? The reflection here. Okay, so if this doesn't exist, we are going to create it. Okay, this is the FBO we're going to use to capture the reflections. Okay, which texture should we put here? We said it has to be a cube map, and that's usually a problem. Although I don't think we have. Okay, maybe I think I shouldn't have to use an FBO. Let me one second, because I think I did a different thing for this. Yes, set texture. Cube map face. Yeah. Okay, yeah, it's a little bit different. We're going to see. I'm not going to create the textures like on the reflection FBO calling the function create, because I need to have a cube map, and by default, the function of FBO to create the textures creates 2D textures. I want it to be a cube map texture. So I need to have a texture for the props. So obviously, if the prop doesn't have a texture, oops, let's create one for it. So prop texture is going to be a new texture. Okay. But I'm not going to define the size or anything, because I need to create it like create a cube map. Okay. It has to be a cube map. That's the important thing, because I don't want a flat texture. It has to be cube map. When you render to a cube map, you cannot render to all the 6 faces at the same time. Although there are some hacks to do that. By default, the usual approach is you bind one of the sides to the FBO. You render the scene from that view, then you bind the other side of the cube map on the FBO, and you repeat the process. So in this case, I'm going to create a cube map. Which size? This is important. The size at which we're going to capture the reflection. 256 maybe will be too pixelated, but it's okay. And the next thing would be if we want to have, we are going to upload any data. Nope, because we're going to compute it on real time. And that's it, I guess. And the format is, I don't care about alpha, because it's just illumination we're going to capture. And as important, the type. I'm going to compute it using a float texture, because I need to have all the bright spots. That's important to keep them. If I didn't put a float, I will lose a lot of information that is important. And that's it. If the prop didn't have a texture, now it has a texture. So next thing is to render onto the 6 faces the whole scene. To render the scene, remember that in this code, I have this function called render scene, where I pass a camera and the scene, and it's going to render everything. I don't have the scene when I capture here the reflection, so we better have the scene. So I don't know, I'm going to put here, probably capture reflection here, and capture reflection here. And when we capture the reflection from here, I'm going to have to pass the scene, which I don't know if I have it here on the, yeah, I have it here. Oh, I didn't have to, I'm silly. I already have the scene as a global, no? Yeah, I have it here. I didn't have to. Anyway, I don't lose anything. So what I need to do here now is for every size of the cube map, and we have 6 sizes, we need to bind one face of the cube map to the reflection FBO. To do that, you go here and say, hey, I want to bind a texture to this FBO. And you say, which texture do you want to bind? I say, from this cube map, I want the texture number, the cube map face number E. So this will mean that the first iteration is the 0, the second 1, 2, 3. Because this function set texture, by the way, I added this function that if you pass here the cube map face and the texture is a cube map, is going to bind only that face. So remember, we have 6 faces on the cube map. It's one single texture, but it has 6 faces, six subtextures, you can say. So with this function, I'm saying this, when I render, I want to render to this texture to the face number E, A, whatever. Okay. So now I've done this, I can bind here, render the whole scene, render scene from which camera? Okay, we need a camera. I forgot to do that. So let's create here a camera. And it's similar to what we did the other day for the radiance. This camera has to be aligned properly with the every direction of the cube map. Otherwise, the cube map could be rotated, or even the faces won't match between each other. Sorry, this is unbind. So which is the camera? For the camera, the other day we were discussing that it has to be a perspective camera. Okay, and the FOB we can decide, but it has to be something like around 90 because you have to match perfectly. The aspect has to be 1, and the near we can go with the classical numbers like this. So this makes sense. Okay, but for the position of the camera, look at. Okay, we need to specify where is the camera. The position of the camera in this case will be where the probe is. We have to specify in which direction is pointing at, like we said, target. And this target has to be the probe position plus the vector in the direction of the cube map that we are facing. And remember, to do that, we have that cube map. Sorry, that function we used the other day. Did I include the cube map? No. I think it's, I don't know, it's vertical harmonics here. Yeah. And in this file here, we have this cube map face normal that tells you the 3 directions, the X, Y, and Z directions when you want to use the cube maps. In this case, I go to here to the number, the E face, and from here, the 0 is the X, the 1 is the Y, and the 2 is the Z. So this is the front. Okay. So we have the target, and finally we need the up vector, and the up vector is the 3rd one. Okay, so let's go here and say this is there and this is there. Okay, so with this camera now we can render the 6 faces, and after finishing we will have this texture here. This prof texture should contain the cube map. Okay, but I don't have a way to test it. So as I said before, always when you capture some information, you need a function to test that you did it right. So render reflection prof, this is the function that we are missing. So let's put it here. The idea here is not just to render a sphere. Okay, so remember, we have 2 ways to render the sphere. We can render like a mapping using the normal, or we can just use mapping as a reflection. So because I was doing something similar before on the shader, I'm going to just have, it's similar to this one, the skybox one, reflection, prof. Okay. And it's going to be very, very similar. The only thing difference is going to be that I need the normal, which I don't have it here. And I'm going to compute the E vector, cool, but I also need to compute the normal vector. Okay, and now compute the reflection vector. So we reflect the E by the N. Oops. Yep. And now we use this vector to read from here. Okay, so this reflection prof is similar to the skybox, but instead of using the E vector, we use the reflector vector. Oops. Sorry, my keyboard is a little misaligned today with my fingers. Okay, so now we have a shader to render the prof, and to render the profs, always first we need to get the shader from the atlas. It was called reflection prof. We need to enable it. I need to pass to the shader the camera information, camera to shader. Okay, I need to, is shaded to camera? So it's the opposite. Is camera and then shade. Oh, yes. I don't have a camera here, so the camera I have to take it from the current thing. Camera. Okay. Cool. Now we have the camera. We have here, we need to pass where we want to render the sphere. For this, we need to have a model matrix that is going to be multiplied. So in this case, we use the prof position. And because we don't want the prof to be too small, maybe it would be nice to have a scale here, as we did the other day. So I don't know, 10. Okay, and then we can pass this information to the shader. Where is going to be the sphere model? And the sphere is the mesh we're going to render because it's the one we need, 3 angles. And yeah, and the only thing we are missing, we are not passing the texture yet. So we go with the texture, which by the way, on the shader, it was called U texture. So I'm going to pass the texture here, the prof texture on the slot 0. Obviously, if this is null, I don't have to do anything. If by any reasons I try to render the prof, but there is no texture attached to this prof, then don't do anything. Otherwise, you're all going to destroy something. And that's it. I think prof, camera position, always important. I think I really did it here, no? Like pass the camera position. Yeah, so I have it. Cool. So I think with this, we can render the profs perfectly without any problem. So I only need to call this function render reflection prof from somewhere on my scene. So when I render scene, okay, this is going to be, I cannot put it here because if I put it here, when I render the profs, I'm rendering the profs. This will be recursive. So, well, no, it won't be recursive, but it will mean that you're capturing the prof when you're capturing when you are. So you will see the prof while you are capturing the prof. So that will be very ugly. So let's do a tiny breakdown of this thing. Something more on the line of saying this is the render scene and this is the render forward. Okay, so this is more the code that does all the rendering. And here I'm going to do here, call this render forward, passing the camera and the scene. Okay, so here I can put more things that are not going to be computed here. And that way I can call this render forward from when I'm computing so that the profs won't be visible. So here I can put this function here. Cool. So now when I was calling the render scene here, I'm going to call render forward. And that way, when I capture in, I won't see the profs. But here in the render scene, if I want to, I can render the profs. So render reflection prof. And which prof? This one. We only have one. So for now, when I execute it, there won't be anything here to render because we don't have a texture. And if there's no texture, there's nothing to render. But indeed, I can do something instead of doing this, of there is no prof, don't render anything. Maybe it would be nice to say that we have a texture that by default is the skybox texture, cubemap. So if the prof has a texture, then it's the prof texture. Otherwise, it's the skybox texture. And we are going to pass this texture here. That way, if there is nothing, at least I will see a sphere on the middle of the scene with the prof. Okay. And when I click the button on my show UI, then it's going to capture the reflection. And here is going to construct the texture if it didn't exist. And it's going to render to every face. Okay. There's still some things I think I should be doing, I'm not doing, but let's try to see if it looks like something useful now. And from there, we can try to fix it. Because one of the things that worries me now is the min maps. I'm not computing the min maps. When you're rendering the 6 sides here inside this texture, I should be generating the min maps. Because I'm not, maybe when it tries to find the min maps, it sees there's no min maps and it's going to look all black. the texture. So just to be sure, I have to here the function generates the image. But for now, let's see what we have here. We have this sphere, as we said before, that only reflects the skybox. We're rendering this sphere in this position, but only renders the skybox. So we can go here, so here, and if we click this button, when at least things are a little bit better loaded, because they are still not loaded, like this texture here. But anyway, let's try now to see what happens. At least the car is here. If I click update reflection, it crashes. Okay. And the crash is interesting because it says that I try to normalize a vector that it's wrong. So one of my matrices is wrong. 1 second. Here, this look at one of the vector is wrong. So let's see which one is wrong. This prof pos, it has a position. This target, it has also position. And this up vector is 1, 0. Oh, no, yes, it's right. So what it's telling me is that when he tried to compute the lookat matrix, there was 2 vectors that were exactly aligned with each other here. So this right vector, sorry, this front vector is minus 1, 0, 0, and the up vector is 1, 0, 0. So if you try to do the cross product, it gives you a 0, 0, 0 vector. And if it has 0, 0 vector, if you try to normalize it, it breaks the application because you can normalize a vector that doesn't have any size. The question is, why is this lookat wrong? If this is the position, and this is where is the camera, where is pointing at, which is not the same. And the reason is, why is this one? If that doesn't make any sense, because this here, the second one, if we're in the I now is the 1. So here, if we go to the number 1, this is the Y. Ah, fuck. This should be an 1. Sorry. As I said, is X, Y, Z. So up the 0 is the X, the second is the Y, and the third is the Z. So I was putting it wrong. Okay. And I'm going to just execute in release, otherwise I'm going to have to wait. But as you see, it's always nice when you have a normalization in any engine, that if there's something wrong here, I have here that if the size of this vector is 0, it crashes the application. Otherwise, I wouldn't have discovered why the camera wasn't looking right. I would have get crazy to try to fix it. So when you do operations that doesn't have any sense, it's all good to crash the application and say, hey, this operation doesn't have any sense, at least so you can debug what went wrong. Cool. So now we have the scene loaded, and we go here and we click the magic button. Okay, as I said, we don't see anything because probably it's trying to use the min maps, but the min maps are not there. Okay, I can try to do a hack now, which is force not to use the min maps from the shader. I don't know if this will work, but at least I can try, which is, this is the shader, no? Yes, remember that you call this lot function and you put 0, 0 here, it means use the first image. So let's try to see if it works. And it didn't work. Okay, so I guess I have to recompute the normal map. Sorry, the min maps. Okay, so just to be sure I'm not forgetting anything because I don't remember exactly the lines to do it. Let's go here in the code I have around here. Okay, to generate the cube maps. Here I create the cube map. I was using 512. Okay, and also here I'm using a vector instead of 1. And here, this is the place where I put the position, look at, enable, function and bind, set texture. More or less is the same, but I didn't put this line here. I need to put this line. Okay, this is the line that generates the min maps. I was expecting that was going to work. Texture here. And this, okay. Let's see if it works now. Also, I never enabled the camera, but the camera is enabled in render forward. Yeah, I don't think I need to do it. But I didn't do the setup. But anyway, let's see if it works. Otherwise, maybe I have to tweak a little bit the function. So here of the reflections, and boom. Okay, this looks bad. And this happens when you don't have the vectors right of the camera. So the camera is not pointed in the right direction. But besides that, there's two errors here because I see the trash ones, two. Okay, so, and this face is repeated twice, and this face is repeated twice. So I did something wrong here. For every of the 6 faces, let me check the code here because it has to be the same. I do the sec texture, then I bind it, then I render. Yeah, but maybe I'm not using the right camera. Let me see. I used camera here. I'm taking that camera, and I do not enable the camera. Yeah, you can see I never enable the camera here, and that's an error because I never enable the camera. That means that it's using the previous camera when it tries to render a new face. And because of that, it doesn't make any sense. So always remember to enable your cameras before rendering anything. Okay, so let's go to rendering, go here, and click other reflection. Bam! And now you can see this cubemap contains every single direction. Okay, super nice, because now when I use this reflection on the scene, so first I'm not using it now. So you can see here, I'm instead using the reflection from the skybox. Okay, so the next step should be to pass this. When I'm rendering every object, I pass the closer or to the camera prof to the shader and use it for the reflection. Okay, and that way I will have this reflection in these objects here instead of having it here on this sphere. Okay, but at least now you know that it's possible to capture a cube map from the GPU. Okay, remember that this, I never downloaded this image to the CPU. It's always on the GPU. Okay, and about the min maps, by the way, if we look at the min maps, it could be interesting to see it. Let's go down like one step on the min map chain, and you can see it's a little bit blurry. Let's go 2 levels on the min map chain, more blurry. Let's go, I don't know, 5 levels on the min map chain. Oops, and you can see it's blurry. It's not as beautiful as the skybox. When you see the skybox in blurry, let's go a little bit more so you can understand what I mean. Like if I go 6 levels, okay, you see the pixels here. I mean, this doesn't look like a blurred image. It looks more like a low resolution image, not like a blurred image. Remember that when we were looking at the skybox, I told you that this format we were using for the skybox, the HDRE, it's a format that where we blur. Every map has a blurred version of the upper one, but a good blur. I mean, we use a kernel and we do a lot of passes. And you can see it like here, when you go down like 3 levels, this looks more like a cube map that it's has a very bad resolution. But if you go here and you do it going down on some levels, like here in the skybox, for instance, if I go here a lot and I go 3 levels down, 4, you can see that it looks blurry. Okay, and that's way better. It looks super nice because it doesn't look very pixelated. It just looks like smooth change. Okay, and that's one of the reasons why if you want to use now this cube map for the reflections, you can do it. And if you want to use the roughness of the objects to go down min maps, you can do it, but it won't look so beautiful. Okay, but it's okay. Most engineers do this. And you can see that generating this cube map didn't take too much, so we can generate it at the beginning. This is not like the radiant that takes like, I don't know, could take 10 seconds, 1 minute, depending on the number of profs. Reflection profs, you won't have so many. I mean, you will have probably 3, 4 around the scene. So you only have to render when you launch the application. And obviously, if you want it, you can try to render them in real time, like every frame, if you have optimized your engine to be able to do that. So if I go here and do this, as you can see, this car is here. If I move the car, it's not on the reflection. Sorry, I should see it's here. The car is not, it's still on the old position. So I have to click here and it will go to the, it uploaded the skybox. But maybe you want to call this function every frame. I'm going to try it. Maybe it's just as a crazy idea that it's worth checking, because I have a function to decide when I want to capture the reflection. Okay, this function here. I don't know, I'm going to do this silly thing of calling this function every frame, okay? Just to try to see how fast it will go, okay? So we're going to capture the reflections every frame, and I'm going to also render it at the end, okay? So let's see what happens if we do this. It's going to go way slower. And also we don't have any lights nor shadows or anything. And these kind of things, when you want to compute it in real time, which you can do, it's very important always that the shadows maps are only computed once, and you are not computing the shadow maps for every iteration of the rendering, because otherwise it will be slow. And you can see it's slow. I mean, but still, it's my GPU managed to go 60 frames per second. And this is real-time reflections, by the way, because you can see here that if I go to this trash bin, I'm going to see it here on the screen. And if I move the trash bin, I'm moving it. Okay, so the reflection matches. Okay, and obviously this is way more than what we had before about the render, and we are doing this only for one place. You have to do this for many, it will be super slow. But some engines do this for like games with cars running, and you can have one probe moving around along the player, and so you always have reflection that matches this player. Okay, but as I said, we don't have illumination here, so if we add illumination, this will be super slow in comparison. So always you have to try to find algorithms that work well. Okay, cool. That was for the more simple reflection, the cubemap. But I want to talk about, because I still have half an hour, I want to talk about the other reflection, which is more interesting for me, is the planar one that is used for water. And if you are going to make any game where you want to have water on the floor, it's always nice to do that. Okay, so for that, I'm going to do the trick I was telling you the other day about rendering the scene. I'm going to do something first. I'm going to remove everything from the scene on the JSON file. So I have here all the road and the prefab, blah, blah. Okay, so for now, I'm going to save it as another name. 1 second, I'm going to copy it here and save it with another name. I don't want to lose the other one, but I want to have another one here. Okay, let's call it scene 2. And in this one, I'm going to remove floors. Let's go here, sorry. Floors, prefab. I'm going to leave only the car, this car over here, one car, and that's it. And maybe the light of the directional light. Moonlight, yeah, this one. Yeah, so we have at least one car and we have one light. Cool. So from my code now, I'm going to go to the application when it loads and load this scene 2. Because I want to have not objects, otherwise they will mess around a little bit the render. Okay. So, and I don't have a floor now. I'm going to also add a floor, yeah, because otherwise I won't be able. But well, anyway, I don't know how I'm going to. We have to have a floor to have the reflection visible, but I don't know how to do it. But anyway, so we have one car. That's it. We'll still have this bulb here. By the way, I'm going to disable the computation of the rendering thing. Otherwise, it's going to destroy this one. Yep. Okay. So imagine I want to render this car reflection. Okay. One option to do that, and as I was talking the other day, one of the crappy solutions that many engines do, it's to have the same geometry flip it upside down, and that's not so complex to do. I can show you that can be done. I mean, if I go here to this car and I duplicate it, I have 2 cars now, you can see here, and to this other car, I hate this plane over here, but anyway, this car over here, I make the scale, I negate this scale, -1, okay, and I put it back up. Oops. Okay. This is the old version. I cannot do this. But anyway, I want to show you that it's possible, but the problem is that the engine doesn't support negative here. So I put negative here, it's going to fix it. No me deja. Anyway, and I can put it up, and if I put it right, it will look like this is the reflection. This is more or less similar to what I was saying the other day about reflections. But something you should realize when I do the negative scale here is that now I'm seeing the inside of the car instead of the outside. Because I'm flipping the sides of the mesh, and that means that the areas that are outside and are facing inside, and that's like, it's like the cool face is wrong, but it's okay. So what I'm going to do now, if we want to compute the reflections, I'm going to have like a reflection FBO. I already have a reflection FBO here, by the way, planar reflection FBO. Okay, so I'm going to do it here. I don't want to create a function to compute it because I'm going to do it. It has to be done by in real time. By the way, you cannot pre-compute the planar reflections in a texture because depending on the position of the camera and the object on the scene, they have to be always synchronized, and that means that you cannot update these like later or once in the frame, because when you move the camera, the reflection won't match. Okay, so for now, I'm going to put it here. So if we don't have this planar reflection FBO, I'm going to create it like new FBX FBO, and I'm going to create one texture for this planar FBO. And obviously the texture has to measure. I'm going to make it measure the same size as the screen. Okay, so in this case, this should be 1 second. Go to get window size. Oops. Ah, okay, because we are going to need render. It's going to be GL RGB, and it's going to be, I should use always float if I wanted to have better quality, but I can also use in Cine chart if I don't care if the reflection is very, very bright. Usually they are not super bright, so I don't know. Okay, so we have a FBO where we want to render the reflection from the okay, of the scene. So the idea is, if we have the car here, okay, and the camera is here, rendering this, I want the floor to have reflections of the car. So the best solution is I'm going to take this camera, put it back here, and render in this direction. Okay. So for that, how I do that? I'm going to bind the scene. Okay. I'm going to render the scene. Okay. And then I'm going to unbind it. So if I do this texture will contain the scene, but this camera has to be a symmetric camera. Okay. So how do we do this symmetric camera? This symmetric camera, over here, is going to be a camera that has the same properties as the other one. Like, for instance, the perspective, set perspective is going to be, even though, I mean, if I want, I can do this. Look, I can do, this camera is equal to this other camera. This is going to clone everything, but I want to change the lookup. The lookup has to be different. So the symmetric camera is not on the same position. It has to be on the symmetric position. Okay, how do you compute the symmetric position? If the floor is flat and the normal is the 0.10, this case, this is super easy because it's just this position negating the y coordinate. Okay, this is the, if it is y, this is the same point with the y negative. Okay, if the plane was sloped like here, like something like this, then you will have to compute the reflective point based on the normal of this plane. And I think that's done with the dot product, but I don't remember now. You can search on it on the internet, but there is a function that tells you, given a point and a normal, how you find the reflected point on the other side. I think that's maybe in the slides. I'm not sure now. So in this case, it's very easy because you go to the other camera here, you get the position, the eye, okay, and you multiply it. You have to negate every coordinate. So in this case, the x is the same. I can do it something like here. It's going to be easier to do here. Pos is camera eye, but that y is equal to, is going to multiply by -1. Okay, and we're going to do the same with the target center. I think we're going to. So here is going to be post target, and the up vector has to be the opposite of the other one. So in this case, could be camera up multiplied by -1. Okay, so if I do it right, and he doesn't like this solution, yeah, it has to be a float. Okay, so now we have a camera that's going to render the scene from the other side. Okay, and here we have to pass the address of the camera. Okay, and now that will render the scene from the other side. We can check if this works if I comment these things here, and I render the scene now. If everything goes well, we should be seeing the scene from the below the car all the time. Okay, let's check if it works or not. Okay, that's going super slow. And it crashes because something was not initialized properly. 1 second. If not planar reflection of VO, planar reflection of VO, I create the texture. and I pass the direction of this camera. Ah, yes, but this camera gets, yeah, sorry. The problem is this pointer of the camera is destroyed, but maybe somebody's using it during this scene, setup scene or something like that. So just to be sure that this camera is not going to be destroyed, I'm going to put it static here, something like this, static camera, okay? This means that this variable is always going to exist. When this function ends, it's going to be still existing. And this way, if this function here uses the camera, which doesn't use the camera, but anyway, somebody uses the camera at any moment and the camera is always going to exist. That's the first thing I wanted to do. And the rest is, I think, is the same. So let's try set up a scene. Okay, I don't think it should be crashing again. Otherwise, I will have to execute in the back. And it's working, but it's crashing. Okay. I'm doing something very, no, execute it again. Damn it, stop it. I'm doing something silly, but I cannot see it. Planar reflection of view is null pointer, so that should work. Okay, let me know it's this the wrong thing. Ah, num textures, damn it. Yeah, I did something very wrong here. This is the number of textures, is one. I was passing GL RGB as the number of texture, and this is a number, by the way, but it's a number super big, like, I don't know, it's like thousands. So it was trying to create thousands of textures, and that's, I have an asset that says you try to create thousands of textures, it destroys the application. Okay. So we render the scene, and we don't see the car, but the car is here, but we are seeing from below the floor, so you do not see it. If I move the camera, it's moving in the opposite direction, but the car is there. So we're rendering from below. You can see the car is there. Okay. Okay. Now we did load another texture. So good. It looks like a reflection. So we're going on the right track. By the way, I'm going to remove the grid because I don't want to have a grid now. Let's do it here. Okay. So, so if I render this on a texture and then I render the texture, I won't see the reflection on the scene because this scene don't have the reflection, but there will be a texture that contains that information. Okay. So one way to do this could be, I can create a plane. I want to see the reflection on the scene, but there is no plane to show it. So one way could be to, I don't know, create a new node, or maybe I'm going to, yeah, because I have the function that renders forward, I'm going to here render a plane. Okay, so I'm going to do something like, I already have a plane, no? No, there's no plane here. Okay, I'm going to create a plane. So here I'm going to create a plane, the size, I don't know, 100, and I'm going to upload to the GPU. Okay, this is the geometry. Okay, I'm creating the geometry of one single plane, and I'm going to use this plane. I'm going to render the reflection on the plane so you can see the reflection. Okay, so I'm going to use here a new shader. Let's call it reflection or something like that. Mirror, maybe. I'm going to call it mirror for now because this is more like a demo. You don't have to code this on the engine. So let's go here and say mirror. Okay, and I'm going to go to this reflection prof, although it doesn't look anything like it. I'm going to just use this one second. So this mirror, I'm going to have here a texture 2D. It's not going to be a cubemap. Remember, the planar reflection doesn't use cubemaps, use a regular 2D texture. Okay, and I'm going to need all these vectors. I'm not going to destroy it, but I'm going to take here a pixel from this texture. Sorry, and the UV. I need the UV of the screen. I need the UV to know in which pixel I'm drawing now. Remember that we have this flag code XY that tells you the pixel, but it tells you in pixels, not in 0 to 1. And when I read this texture, I need it from 0 to 1. So I need to divide it by the ERES, multiply by ERES or divide it by the resolution. Okay, so in this case, I need to have this uniform vector 2, the inverse of the resolution of the screen. So if I multiply this inverse of the resolution by this, the pixel in pixel coordinates, I get the UV from 0 to 1. Okay, and this is the UV I'm going to read here. Okay, so we have this mirror thingy, mirror shader, and here I want to render this flat plane here. So what I'm going to do is render the scene. Okay, and at the end, it's going to render every single node. And I'm going to add an extra node, which is going to be first, I need to have the shader. It's going to be the this shader. I'm going to enable it. I'm going to pass the camera to shader. So to the camera we're using now, to this shader. And I need to specify where I want to render this plane. I'm not going to do anything. I'm going to render in 0, 0, 0. So this could be the model. Sorry, plane now. Model. And I have passed everything I need, the model and the texture. So always in this case, the texture is going to be from this planar reflection FBO, the fixed color texture. And on the slot number 0. Okay, and I'm sorry, I forgot the inverse of the resolution, which by the way, I didn't call it UERES, I think. I prefer to call it UERES. Okay, and this is going to be, I have the size of the screen, not here. Yeah, I'm going to bring outside. So I usually prefer to use the FBO size. Yeah, let's call this reflection texture. So this way I can remove all this long line, and here I can put the 1 divided by the width of this texture and 1 divided by the height of this texture. And I'm using this texture because I want to play with the size of this texture later. So I can show you the trick where you render. No, it has to be the size of the screen. Sorry. If I reduce the size of the reflection, I will do that to show you that you can optimize if you reduce the size, but it has to be the size of the screen where you're rendering. Otherwise, you won't have the right UVs. Okay, so finally, I have to render this plane, render with the triangles. And I don't want to have any kind of blending for now, so you'll disable the blending. But I do want to have the depth test, so depth test. Okay, so quick recap. I will render first the reflection on this texture, and then I will render the whole scene on the screen. And after I have rendered the whole scene on the screen, I will render another plane that contains the reflection on the floor, okay? Two things to take into account here. This only works for the floor. Obviously, if you have a mirror on the wall, then you will have to apply, the model have to change to the position, but also remember that you will have to compute the symmetric differently. And as it works, because when I'm rendering the reflection, I'm not rendering this plane because I don't want the reflection to contain the reflection. That would be like a recursive situation, and you don't want that. So you render the scene, and I also render here. The right way to do this will be that it has to be a flag on the material to say this material uses planar reflections. And if that's the case, you don't upload the cubemap, you load another texture, which is the planar reflection texture. And on the shader, you use that one like I'm doing here. But anyway, so let's try first to see how it looks like this. It's going to look wrong. I have to tell you how to fix. There's going to be a tiny error now. And the reflection is going to be wrong aligned, but we will fix it on the shader. So we have here the flat plane with the reflection. As I said, it's not matching. You can see that it matches vertically, but not horizontally. And the reason is because to do the symmetric camera, I invert the target and the position, but I should invert it horizontally. I didn't invert it horizontally because it's a little more complicated to do that. And because I didn't do that, it's the opposite. You see that the lights are facing in this direction, but then the reflection is facing to the other direction. But it's very easy to fix this. I go to the shader here and I say, hey, the UVX has to be the opposite side. It has to be the inverse of what's on the other direction. If I do this, ta-da, I have here my reflection that matches perfectly with the car. Okay. So I have this plane now that has the reflection, and you can see there's no car below. Okay, this is not a hack. This is the nice way. Okay, I computed the reflection of the whole scene. You can see here, if I go here to the textures, there's the texture of the reflection here that contains the whole reflection. Although at the end on my scene, I'm only seeing this part of the reflection. Okay, so I'm wasting resources painting too much scene that is not going to be visible, but at least I have a reflection here. I cannot try to read the min maps as far as I know. If I try to see the min maps, it won't work because this texture doesn't have any min maps. You can see here, I forced to load the min maps and it's still using the same one. This texture doesn't have any min maps, okay? And also, usually many GPUs, you cannot generate min maps from a texture that is not a power of 2, okay? I'm not sure about my current GPU. Maybe my current GPU supports that, so maybe I can do it. By the way, I have this dark patch of the transparency thingy, and I just try to remove it a little bit. So it's not so annoying here, this plane here, so maybe I can put it, I don't know, here below the reflection. And okay, so we have some sort of reflection, and it always will work very well. But we have a problem now, okay? The problem is the next one. If the car sinks inside the reflection, okay, let's go that, take the car and sink it below, okay, you will expect something like this, which looks nice, but you can see something weird happening here. You can see that this part of the reflection is visible, although it should be not visible, okay? And you can see there's something weird going on here. It looks like this part looks nice, the reflection, it looks good, but there's some parts that look wrong, okay? The reason why some parts look wrong, like I put it like this, for instance, is because when I'm rendering the car from below here, and in this case, when I'm rendering the car here, what I want to render should be only this part that is outside of the plane. The part that is inside of the plane shouldn't be visible. But because I'm not doing that, I'm capturing the inside of the plane geometry inside the reflection, which doesn't make any sense, okay? So if you want to solve that problem, there is one way to do it, which is not painting the pixels that are inside the reflection, okay? And if, in this case, if it's a planar reflection, it's on a floor, it's very easy. You only have to go to every pixel that you are rendering, doing the reflection part. For instance, where I was rendering here on the light FS, when I'm rendering every pixel of the scene, the car, the house, whatever. And I'm going to say that here we are discarding the pixels that are transparent, but I'm going to add also another discard, and the discard here is going to be if the wall position Y is smaller than 0. That means that it's below the floor. If that's the case, I'm going to discard this pixel, okay? This only works if the floor is the reflective plane. If the plane is a wall, then you will have to find if this pixel is in one side or the other side of the mirror. And to do that, you can do a dot product, and the dot product will tell you if it's in one side or the other. But for now, if I do this and I reload, you will see that now it matches. So you take the car and you can see that the reflection matches because even the areas that are below, they are not rendered. And if I go up, it appears, okay? So that's how you do planar reflections. And lastly, because I still have some minutes, maybe I can try to see if I want to have, I can do some tricks here. For instance, one thing I can do if you want is what happens if we render to half the resolution. Okay, so let's do this. Could be useful because you know that the bigger the resolution, the more time it takes to render. If we use half the resolution for the reflection, it's going to be a little bit faster. Obviously, the quality is going to be worse, but it's a trick that many people use for reflections when they have planar reflections, like something on like water on the sea. So here you can see, I have the car here. I'm going to take here, and you can see that still looks very nice. although I can tell you that this is half of the quality. Okay, this texture here has half of the quality, and you still cannot see it unless you pay a lot of attention. Okay, and also here on the reflection, I mean, if in reality it won't be so perfect reflected. There will be Fresnel, there will be attenuation. Like if I go here to my shader here I did for this plane, first the color will be probably way darker, something like this. Well, not so much, but something like this. The reflection, okay. And also, obviously, as I was saying before, we should have some sort of Fresnel. So you can also have the Fresnel factor, as I did before, which was the PO of the dot product of E and N, but 1 minus this, but also clamping this from 0 to whatever. Okay, so if I do this is Fresnel, and I use this also multiply here. If I do reload, maybe I didn't do it right. 1 second. Is dot product between E and N. I think, sorry, it was negative. No, but it crashed because, yes, I put the PO. I forgot to put, I'm silly. I put the PO, but I forgot to put the coefficient here. Let's see now how it looks like. If I take the car, I'm going to make it lower. Loop, sorry, 1 second. I'm going to remove maybe some factors here. And here, I'm going to remove this factor here. And for some reason, the Fresnel doesn't work. This is a factor. I want to see this factor because, no, well, anyway. And the dot product max, and then I'm going to remove the PO for now because I think it's interfering by somehow. Okay, and now one of these factors is not normalized. This is not normalized. So this vector was super big. Okay, so now you can see that if I look at the reflection directly, it has more reflection. If I have look on angle, which is the opposite, right one, it has to be something like this. Okay, so when I see the reflection from the top down, it's not so reflective, but when I see it from the side, it's more reflective. Okay, and as I was doing before, this usually you have to put here some curves because otherwise it doesn't look very beautiful. Something like this. Yeah, maybe. Yeah, that's it. Okay, so as I said, a cheap solution to have reflection. And here, this reflection is half of the resolution, and you still cannot see it's half of the resolution. So that's nice. Even if I go a little bit deeper and say, okay, 4 times the resolution. Okay, let's go with 4 times. And also, by the way, I want to make the plane bigger because I want to cover the whole car. So maybe, I don't know, 300 will be better. Yeah. So I execute this. Okay. Okay, so we have here the car, and we have here the reflection. Why is it not so big now? I changed the size of the plane, no? Prof position, no. I mean, I want to change the plane size, this one. But anyway, and here we have the reflection, okay? And this, you can see now it starts to look pixelated. I don't know if you can see it, but it looks very pixelated in comparison. So it's not so good. Also, I'm not using linear interpolation, I think. It looks like it's not linear interpolated. So anyway, it looks a little bit bad. But if I wanted to go a little bit further, I can try to have min maps of this image. The problem is that when I generated the reflection texture, I don't have min maps. So here, when I generate this, I'm not generating the min maps. I can try to, like when I have this texture here, this reflection texture, generate min maps. Let's try to see. If I try to generate the meme, I don't think it will allow me, but that means that if I go to the shader now here on the mirror, I can go down maybe, I'm going down already too. Okay, let's try to see if it looks very blurry. I don't think so, but maybe. Because I tried to generate meme maps of a texture that is not square, and I know that not many GPUs support that, but I don't know if OpenGL is going to block it, or is the GPU which is going to block it. Oh, it works. That's nice. So you can see, I don't know if you can see it. So here we have the reflection is very blurry. Yeah, because the min maps are not the best solution to do blurriness. So it's a solution. Let's go a little bit upper. So why it's important that you can control the blurriness, because you can use here information about the material of the floor. Like if the floor is very rough, then you will go down more min maps. If it's less rough, then you will go less, and that will mean that you can have, I don't know, areas with water. I don't know. And some engines do that when they want to have skin space. Sorry, planar reflections. Okay, and that's it. That's the two ways that you can have reflections in your engine. The third one is the complex one that it requires like maybe 3 weeks to code, and we don't have time, but it's easy to implement this one. If you want to implement this one, I will obviously give you points if you try to, and remember how you do that. You have to have a way to say which object has these planar reflections. And so currently in the material, we don't have information about that. So here in the material, there is nothing here to tell you that this object should be using planar reflections or not. But one way to do this is that you can send to the shader when you're rendering the full scene, okay, you can send to the shader some sort of information as saying, okay, this area here, there is a planar reflection texture, okay? So when you're rendering a pixel, if the wall position is here, you don't have to take care about you use the cube map, okay? You use the regular cube map to fetch the reflection. But if one pixel, the distance of one pixel to the plane where you computed the reflection is smaller than, I don't know, a threshold, something like this, 001, okay, that means that this point is probably over the surface of the floor, and then instead of using the cube map, you use the planar reflection, okay? But if you do that, keep in mind one thing, and it's important, is that be careful when you're rendering the reflection from below. Be careful when you render this floor that you don't read the same texture while you are rendering, because here it could happen. Imagine that during this phase here, when I'm doing this, if inside the render forward, I'm reading the reflection texture, this texture here, that will mean that I'm rendering to one texture which I'm reading from. And you cannot write and read on the same texture at the same time. That produces strange behavior on the GPU. So be careful with that. So one thing to do that is that you disable this texture when you do this phase. When you're rendering forward, there is no planar reflections. You render like a regular cube map. But when you render the final scene, you enable a flag to say, hey, now you can use the planar reflection texture. And if it finds it, then the shader will use that one. And then usually you have to send to shader also what is the position of the plane and the orientation of the plane, okay, which is usually done using 4 values, which are normal and distance to the center, to the minimum distance to the center from the plane. This is the formula of a plane. It's just for numbers. And it's easy to check if the point is very close or not to that plane. If you want to implement planar reflection, as I said, it's something that is cool to implement. And if you want to have water or something, it looks super nice, okay? And that's it, I think, for today. No more things. Next week, we're going to talk about more atmospherical effects and also how to add post-processing algorithms to your engine to make it look more interesting. And last week, if I have some time, I will talk about another feature that is nice to code and looks nice on the scene, that we just call it decals. And that will be everything I have to teach you about GTR. Okay. So if there is no questions, implement this feature in your engine, try to play around with these ideas. If you want to extend the entities, it would be nice. I didn't do it much on this course, but remember that you can create new entities very easily just by inheriting from this class, the base entity, following this structure that I have here, which is you have to put this word and say the name of the class, what's the type, and this is the icon, by the way, that shows on the editor. And more important than that is remember that you need to instantiate your new entity here. So you can have a reflection prof entity or a planar reflection prof entity. You can choose from that. Okay. So that's it. See you on Monday on the seminar, and please come. Otherwise, I cannot follow you what you're doing. See ya. All right, Monday is holiday. I forgot about that. Okay, then I will see you on Tuesday. So there's no seminar next week. Yeah, that's true. Okay, use wisely the time that you have then. And I will be probably on Discord around. So if you want to throw up questions, I can answer them. Okay.